Good morning, everyone. Today we're going to be kicking off Chapter 4, Lesson 1, Day 1, Representing Relationships. We wrapped up Chapter 3. I'll be checking in with people about follow-up on quizzes and things, but today we're moving on to Chapter 4. So our objective is to translate tables and graphs into linear equations. Need the same materials. Watch for these announcements in the videos, and here we go. So today we're going to be looking at tables, graphs, and equations. And as a quick reminder, recall that an equation is a mathematical sentence stating that two quantities are equal. A linear equation is an equation with a graph that is a straight line. Some equations contain more than one variable. So for our first example, we're going to be looking at information in a table. The table shows the number of liters in quarts of liquid. We're being asked to write an equation to find the number of liters in any number of quarts and describe the relationship in words. So we've got a table here with quarts and liters. You can notice that as quarts increase by 1, liters increases by a positive 0.95. The rate of change is the rate that describes how one quantity changes in relation to another quantity. The rate of change of quarts to liters is 1.9 minus 0.95 over 2 minus 1. So we're looking at our slope equation, y2 minus y1 over x2 minus x1. For our final answer, we end up with 0.95 over 1, or 0.95 liters in every quart. So we're going to let L represent the liters and Q represent the quarts, and the equation would be L equals 0.95 Q. So now that we have our equation, we can look at this scenario for number 2 about how many liters are in 8 quarts. So if we use the equation L is equal to 0.95 Q, again L is for liters, Q is for quarts, we plug in 8 for quarts, we multiply 0.95 times 8, and we get 7.6 for an answer. So we can say there are about 7.6 liters in 8 quarts. So let's try this problem as an example. The total cost of tickets to the school play is shown in the table. We've got number of tickets represented by T, 1, 2, 3, 4, and total cost in dollars represented by C. We start out at 4.50, we go to 9, 13.50, and 18.0. So if we're looking for our rate of increase, we're moving up 4.5 for each ticket. So A says write an equation to find the total cost of any number of tickets and describe the relationship in words. So our equation would be C is equal to 4.5T. So basically the cost is equal to $4.50 per ticket. We could see that right here in the unit rate, where number of tickets is 1, total cost is 4.5 or $4.50. So now for B, we're asked to use the equation to find the cost of 15 tickets. So we use our same equation, C is equal to 4.5, plug in 15 for tickets, and when we multiply, we get C is equal to $67.50. So for A, our equation is C is equal to 4.5T. And for B, our cost is $67.50. Let's take a look at one more example in the guided practice. The table shows the total number of text messages that Brad sent over 4 days. So we've got days increasing by 1, and we've got total messages increasing by 50. So again, we can pull that unit rate out. For every day, there's 50 text messages. So now we need to write an equation to find the total number of messages sent in any number of days and describe the relationship in words. So our equation is going to be M for messages equals 50 times D. And to spell this out and explain it in words, he sends an average of 50 messages per day. Now we need to use the equation to find how many text messages Brad would send in 30 days. So we just apply our equation, m is equal to 50, plug in 30 for days, and we get 1,500 messages. Your assignment for today is page 273, number 1, and you can access the homework assignment and the answer key right in Canvas.